The human ear is comprised of three different parts, the outer, middle and inner. Starting with the outer part of the ear, the visible external fleshy part shown is called the pinna, which is specially shaped, helping us to determine the direction that a sound is coming from. Focusing in on the auditory canal, we can see the circular object called the eardrum. Sound hits the outer layer of the eardrum, known as the tympanic membrane, causing it to vibrate. Now we are at the middle part of the ear. These three tiny bones are called, from left to right, the malleus, incus and stapes, or hammer, anvil and stirrup respectively. The vibrations generate energy and channel them through these three bones to the stapes, causing a chain reaction. The stapes has a surface area of around 3.2 mm squared, whereas the eardrum has an area of around 55 mm squared. Therefore, the initial sound pressure level is multiplied by up to 22 times once the vibration reaches the stapes. The eustachian tube is also located in this area. It equalises pressure generated between the middle ear and the throat. The first element of the inner ear is the cochlea, a coiled up tube which is internally split into three different channels. Above the cochlea are the semicircular canals, a part of the vestibular system, which work with the brain to interpret and create the sensational balance. Zooming in on one of the channels inside the cochlea, we can see how sound waves are transferred through the stapes and into the cochlea. They travel along the cochlea and meet these fibres on the basilar membrane. The fibres represent different frequencies that humans can distinguish between, specifically between 20 Hz and 20,000 Hz. They resonate when met by a sound wave, triggering these hair cells next to the fibres. When they vibrate, the fibres generate electrical impulses that are sent along the auditory nerve to then be processed by the brain. What I find the most mind-blowing aspect of this extremely complex system is the fact that the whole process lasts just a few milliseconds every single time you hear something.